Hello guys, welcome back to our channel. So in this video, we're going to learn about building a machine learning model. So in the last video, which is part 1, we had learned about the basic topics and definitions about machine learning. But in this video, we're going to learn and build up a diabetes prediction machine learning model. Okay, so I'll be telling you each coding terms step by step so that you guys can understand in a better way, right? So let's start. So first of all, before coding in any part in any studio, we need to import the libraries, right? So first I'll be importing numpy as np, right? So this is the first library. So the next library is import pandas as pd. Okay, next from sklearn dot preprocessing import standard scalar, right? So we use this for scaling the values. Scaling the values means we're going to make the values equal, so we use the term standard scalar, right? Next we're going to update from sklearn dot model selection import train test and split. Okay, so over here we are importing the train test and split function. So basically this it helps in training the data, then testing the data and splitting the data. So basically here splitting the data means we're splitting the entire data set into training data and testing data, right? So we use this term. So next which you're going to import is sklearn. From sklearn import svm. So basically here svm it helps in the classification parts, right? svm it means support vector machine. So basically this algorithm it helps during the classification. Okay, now from sklearn dot metrics import accuracy import accuracy score. So this particular function it helps in this term it helps in finding the accuracy score, it helps in calculating the accuracy score, right? So this is all about the importing part. I'll be running this. It's taking some time over here. Yeah, it is being implemented successfully. Yeah, now next which I'm going to do is I'm going to load the data set. Loading the data set, right? So as we are making the model on the basis of diabetes, so I'm going to name the data set as diabetes prediction. Diabetes data set, yeah, diabetes data set is equal to pd dot read csv and I'm going to copy the path over here. The path of the data set will be going home and you'll find the diabetes data set over here. Yeah, I'll copy the path and I'll paste it over here, right? So by this we can load the data set. Even this is being implemented successfully. Now the next step which you're going to do is printing the first 5 rows of the data set. I'll be writing this in the comment, and for comment we use this hashtag over here, right? hashtag. Like for comments, we use this. Now I'll be printing the first 5 rows of the data set. Now how to print? So basically there's one term over here which I'm going to use. As we have named our data set diabetes data set, I'll be using the same term over here, right? Diabetes data set dot head dot head. Okay, dot head. Now I'll be implementing this. Yeah, as we can see, we got the first 5 rows of the data set, right? 1 2 3 4 5, and the columns are the pregnancies, glucose, blood pressure, skin thickness, insulins, BMI, which is a body mass index, diabetes pedigree function, age, and outcome. Over here, outcome is what? So, like based on all these values, the final outcome is 1. So over here, 1 means the patient is diabetic. Now in the second row, we can see on the value of, like on the basis of these values, the outcome is 0. 0 means the patient is non-diabetic. Got it? So this continues 10101 over here. So this is all about printing the first 5 rows of the data set. So over here for printing, we use the term head dot head. Okay. So this is just for visualizing the data set. That's it. Like it's not compulsory to do so, but if you want to do, like if you want to have a clear view of the data set, then we can use the term head, right? Yeah. Now I'll be using the number of rows, like how to calculate the number of rows and columns in the data set. So I'll be writing the comments calculating the number of rows and columns in the data set, right? So as we're given our data set name as diabetes data set, right? Diabetes data set. So dot describe it. Describe, right? So it's not describe, it's shape. Yeah. Now when I've run this, we got 768,9. Now what do you mean by 768,9? 768,9 means in the total, in the whole data set, there are 768 rows. Rows means like this 1 2 3 4 5, right? And there are 9 columns. Columns means 1 2 3 4 5 6 7 8 9. Take straight are the columns and side are the rows. So totally in our data set there are 768 rows and there are 9 columns, right? Okay. So this is all about the rows and columns. Now we'll see in the whole data set how many patients are diabetic and non-diabetic. We'll be having a short information. So for calculating this information, we'll be using a term again, diabetes data set, the same name like which like we had given over here, right? Okay, diabetes data set outcome dot value counts, right? Okay, now if I run this, I'll be getting the outcome 0 500 and 1 has 268. Now what do you mean by this output? So by this output we get to know that 0 means the patients are non-diabetic. But how many patients are non-diabetic? It's over here, 500 patients are non-diabetic, and 1 we have the output as 268. So what do you mean by 1? 1 means the patients are diabetic, the patients who are diabetic. So there are totally 268 patients who are diabetic. Okay, so basically, like, this information is not required, but for your better understanding, we need to do this before implementing any machine learning model, right? Because by this we can visualize the whole data set, and we can implement it, and we can load the, like, the correct information into the machine learning model. So this is the purpose of doing this. Okay, no, good. Now we'll be seeing, we'll be calculating the mean, the average of each column. Now how to do this? Diabetes, sorry, diabetes dataset dot group by group by outcome dot mean, right? Now if we run this, we'll get totally there are 9 columns. How many columns are there? 9 columns over here. 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? 3, 3, 4, 5, 6, 7, 8. Hold on a second. 2, 3, 4, 5, 6, 7, 8, 9. Okay. So basically there are 9 columns. Okay. So yeah, total there are 9 columns, but over here we done diabetes dataset dot group by outcome. We took one column over here, means based on the outcome we done the average of each column. Okay, based on one column we done the average of each, like, for each column. As we can see here, we grouped the average based on the outcome. Okay, now see here, outcome is equal to 0, dot mean is finding the average, right? So outcome is equal to 0 means the patients who are non-diabetic, the average of those in the column of pregnancies are this value. I repeat, for this 0, which means the patients who are non-diabetic, the average value for glucose is this value, and this continues, so on it continues, right? The same applies for diabetic patients as well. You can see here outcome is equal to 1, then the value, the average of the diabetic patients for the column pregnancies are 4.86572, as you can see here. This continues, so on for glucose, blood pressure, skin thickness, insulin, BMI, and so on columns, right? So this is the mean based on the outcome, like we calculated based on the outcome, like the patients who are diabetic and the patients who are non-diabetic, we calculate the average of for each column. Got it? Now we'll be separating the data and the labels. Now I'll be initializing a label called as X, capital X is equal to, I'll be first writing the comment over here, because comment, like good comment, it helps in better understanding, right? Even I use, because I like I practice the same as well, because it makes me easier to understand like what I have implemented. So separating the data and the labels, so I'll be giving X value, X initialization, diabetes dataset, right? Diabetes dataset dot drop. Drop means we are dropping one column, we are removing one column, that's it. Drop columns, give the column name over here. So which column I want to drop, that is the outcome column we want to drop, okay? Comma, axis is equal to 1. So basically this is just a syntax, like it's just format we should follow when you are dropping the column. Don't again think, like don't overthink about it, just understand the format for dropping the column, that's it, right? So basically we are dropping the column outcome, right? And for y is equal to diabetes data set, and the outcome which I'm going to use is outcome, right? We came here the capital O, right? So basically we are dropping the column, yeah, in the X, right? And we are initializing the only the outcome values in Y. So basically, why are you doing this? Because we want the machine learning to we want the machine learning model to understand that X, it has only the input data, right? That like the model should have only the input data, right? Because if you give even the outcome, then it becomes a waste, because we want the model to predict. We don't want supervised learning, we want unsupervised learning. Because if you give this output as an input to the model, then the model can understand based on this values the output is this and this. But we don't want this, so we drop this table, and accept this table, we initialize all these columns for X, and for this outcome we give it to Y. Okay, because the machine learning model should understand that the output should be given by the model only, right? So we store the output in Y, and we store the remaining columns in X. Okay, so when we implement this, yeah, this is being implemented. Now when we print X, we'll see the output. Over here, when we implemented this, as I told you, in the X, all the columns are present except outcome, because we dropped it, right? As we can see in this, we dropped the outcome column. So except outcome column, all the columns are being printed. You can see over here, right? You can see over here. All the columns are there over here. All the columns are there except outcome, because we have dropped it. And over here, Y, we are just stored the value. Now if you print even Y, we can see print Y. See here in the Y, we can see we have stored only the outcome value which is over here, right? Outcome value 101, which is the output Y. Got it? As I told you the reason before, because we need the machine learning model to understand like what should be output and what should be the input. The input should not contain the output, right? So we stored the output in Y, and we stored only the input in X. Got it? Now I'll be going to the next part, that is scalar. Now I'll be going to the next part, that is data standardization. Data standardization. Okay, standardization. Yeah, data standardization. Yeah, now it looks good. Yeah. Now here, first I'll be using the term scalar. Scalar is equal to standard. Standard scalar. Standard scalar. Okay. So basically over here, standard scalar, it helps in scaling up the values. So what do you mean scaling? Like it makes the values equal, right? It makes the values identify like it makes the values easier for the machine learning model to understand. That's it. Because of this we use standard scalar. Okay, now if we run this is done. Now if you do scalar dot fit x, now what do you mean by scalar dot fit x? Scalar, I took this like variable itself over here, dot fit x. Okay, fit x, I'll take capital X, right? Fine. Now fit, now what do you mean fit? Fit means we are we are making the model to learn about the data. That is the meaning of fit. We are training the model based on the data. That is the meaning of fit. Like it's nothing else. Okay, scalar dot fit x. Okay, now we'll be implementing this. Like ignore this. Now standardize standardized data is equal to scalar dot transform x, capital X. Okay, transform x. Then we'll be printing print standardized standardized data. Now I'll be telling you what happened here actually. Now we have named one variable called standardized data. Okay. Then we used scalar dot transform x. Here we are transforming the values. Here we are transforming the values because the machine learning model should understand the values. So we use the term transform. Okay. Basically standard scalar it's just one like a model, like it's just one model we can say. Okay. So based on this we are scaling the data, we are making the data, and we're making the data understandable, and then we are using the transform data to make the data even more understandable for the machine learning model. Got it? So we can see here, as the values over here were like random values. Some values were 148, some values were 60, some values like, and some values were 0, and some values were 23, right? But over here we can see all the data are similar. They lie between the 0 0.6, 0 0.8, 0 0.1, like between 0 0.1 and 0 0.8 the values are lying. Okay. Like it went even like negative also, but they lie between is like 0 0.1 and 0 0.8, like between this like between this only the values lie. That's it. Okay. So this is all about the result. Now next part will be going is we'll be initializing this part, which is very different. Yeah, over here 0 0.7. Got it? Now this is all about the standardized data. We are standardizing the data, as I given the heading, data standardization. Now after doing the data standardization, we going to train, test, and split the data. Okay. Now first I'll be training the data. So I'll be using the term x train, comma x test, okay, comma y train, y train, comma y test. Okay. Now after doing this, I'll be doing equal to train split x, comma y, comma test size is equal to 0.2, comma stratify is equal to y, comma random state is equal to 2. Now what is the meaning of this? So here we took the x train and x test. X train means like a training data, of course. So basically x train, y train are the training data, and x test and y test is the like testing data. That's it. Okay. Now basically we are then splitting the data. Okay, splitting means we are splitting the data into training data and testing data into two parts, right? So okay, we are splitting the data into two parts, that is training data and testing data. Okay. Now how much are splitting the data set? Over here I can tell you that we're splitting 0.2%. As you can see here, test size is equal to 0.2. 0.2 means 20%. Now if the test size is, which is testing data is 0.2, that is 20%. I repeat, if the testing data over here is 20%, then the remaining part is training data, that is 80%. Okay. Over here the test size is 20%, which is 0.2, and the remaining part is training data, which is 80%, that is 0.8. Got it? Now we use the term of stratify is equal to y. So basically stratify, it is used for even distribution of the testing and training data. So because of this we use the term stratify. Now next we'll move on to the random state is equal to 2 part. Now in this what we do is the randomness of the data is being controlled. Okay. Now when we get the training data and the testing data split, then After running each time, we must get the same data. It should not be the data should be mixed. After, I repeat, after splitting the data into training data and the testing data, after each run, the data should be same in each test phase and train phase. That's it. That's the meaning of random state. Okay. Now I'll be moving to the next part. Next train is done. Now when we run this, sorry, train split. What happened over here? Random state is equal to 2. That's fine. Train split is not recognized. Okay, it is not train test. Okay, so I missed one term. Sorry, it is train test split. As I told you, it is train test split. Test size is 0.2. Again, over here I should add on this one. Then it may work now. Yeah, now it's implemented successfully because I missed some terms like this marks and all. I had missed them. Now I'll be moving to the next part, that is training the model. Okay, now I'll be doing the class comment over here, that is training the model. Now in this all before we have learned like in this part we have learned about the data standardization, and we separated data and the labels, and we already know the reason behind this. Okay, then we then we use the transform function and scalar function over here. Okay, now we'll be training the model. So that is the next part over here, training the model. Now for training the model, I'll be using the term classifier. So classifier dot fit x train comma y train y train. Okay, after doing y train, I'll be doing this. Classifier is not okay. Okay, sorry. Before this, I'll be deleting this box. Yeah, we'll define classifier before implementing it. I forgot it. So classifier is equal to svm dot svc kernel is equal to linear. Okay, so basically we initialized a term called classifier, then we are loading the svm data over here, svm model algorithm. svm means support vector machine. So basically this algorithm is used for classification as well as regression. Okay, and this kernel is equal to linear means this helps the svm to classify. That's it. Okay, now after the now I'll be implementing this too. Yeah, now I'll be implementing the classifier mode. Classifier dot will be fitting the data into the classifier. Okay, fit x train comma y train. Now after running this, classifier is okay. Spelling mistake this time. Everything is correct. Only the spelling mistake. Yeah, it's being implemented successfully. Okay, so basically we are giving the training data, that is x train and y train, to the classifier model over here. Okay, fit like we are training the model because with the help of this training data. As I told you, fit means we are making the model train using the training data. That's the meaning of fit. Got it? Now next what we'll do is we'll do the model evaluation. I'll be writing in the comments model evaluation. evaluation. What is the evaluation? Okay, now I'll be using X train prediction. X train prediction is equal to classifier dot predict X train. Okay, X train. Now if I run this, classifier again spelling mistake over here. Ooh, yeah, this is being implemented. Done. Now after this, I'll be so basically X term prediction is like a variable which I've given over here, and the classifier dot predict means it predict based on the training data over here. Okay, like that's the meaning. Now if next if what if I do is if I do training data, I want to find the accuracy. Then how to do it? Training data accuracy. Training data accuracy is equal to accuracy score X train prediction, comma Y train. Okay, run this. It's now over here the training data accuracy. Like if you want to find the accuracy of the training data, then over here what we do is first we do the prediction based on the training data. As I've written near the code, extra prediction is equal to a classifier dot predict extra. Now if you want to find the accuracy, then we give the input or like extra prediction, the prediction of the model, and the output which must be needed over here. So it knows the, like it compares the value and it gives the accuracy. That's the meaning of this whole sentence. This sentence is there, right? Like the meaning of this is it compares the wide trend and the actual prediction made by the model, then it compares it and then it gives the accuracy. Now the last step is printing the accuracy, right? Printing the accuracy, sorry, print printing the accuracy, printing the accuracy score, accuracy of the training data. Okay, it is training data accuracy. Okay, now I'll be running this training data accuracy again. The same step over here. Training data accuracy. Yeah, as we can see here, based on the model prediction, okay, the accuracy of the training data is the accuracy of the model based on the training data is 0.78. So 0.78 means it is 78%. Now this accuracy is based on the training data. Now next we'll find the accuracy based on the testing data. Got it? Now again we'll be doing the same thing. Comments, accuracy, accuracy, accuracy score on the test data. Now I'll be doing X test. I'll be doing the one thing. I'll be copying the same thing. I'll copy and I'll paste it over here. It the same at time. X instead of training, I'll just replace the test. Yeah, test very straight away. Yeah, I'll be just writing the term test. That's it. It's same at time. Control C, Control V, testing data accuracy, X test prediction, and Y test. Now I'll be running this. What happened over here? Okay, I'm not printing it. Sorry, printing. Sorry, print accuracy of the of the model based on the testing data, comma, testing data accuracy. Now I'll be running this invalid syntax. Why it is invalid syntax? Okay, over here I made a mistake. Yeah. Now the accuracy is 0.77%, which is 77%. Okay, so basically the model, it has more accuracy in the training data if compared to testing data, because the accuracy of the model based on the training data is 78%, and the prediction of the model based on the testing data is 77%. So this is the difference, and this is the prediction we got by this. Okay, now after doing this, everything is ready to go. Now we'll make a real predictive system by doing everything from start. Okay, now I'll be doing, and now I'll be making the real predictive system. Okay, making the real predictive system, real diabetes, diabetes. Okay, now this is the comment 10. Now I'll be giving the input data is equal to 5 comma 166 comma 72 comma 19 comma 175 comma 25.8 comma 0.587 comma 51. So are there 9 columns? 1, 2, 3, 4, 5, 6, 7, 8. Okay, sorry, 8 columns, not 9, 8 columns, because we have dropped this column, right? The which is this, like we have dropped this column, outcome column. Now this is the input data which will go to the model. Now next we'll be giving, we'll be changing the input to numpy array. So changing the input to numpy array. For to be more specific, I'll be using input data to numpy array. Now we're going to change the input data to numpy array. We are doing this because we need the model to understand about the values. Okay, we are changing the real-time input data which is present over here to array, because we need the model to understand. That's the reason we're doing this. That's it. Now I'll be using input data as numpy array, as numpy array is equal to np as np dot as array input data. Okay, we are changing the format over here, so this is being implemented correctly only, so no worries in this. Now we're going to reshape the data, reshaping the data reshaping the we are reshaping the data because we need the model to understand that there is only one instance, that there is only one example. There are not multiple examples. We have an example of only one person. That's it. Only, as you can see here, we have an example of only one person, not multiple person. That's it. So reshaping the data, reshaping the array, as you can say. To be more specific, I'll be using more specific terms. Reshaping the array. So input data reshaped is equal to input, sorry, input data as numpy array dot reshape 1 comma minus 1. Okay, so here 1 comma like minus 1 means like we are using only one instance as an input, okay, for the model. That's the meaning of reshape 1 comma minus 1. That's it. Now after reshaping we're going to standardize it. Standardizing the standardizing the input data. We are now what do you mean by standardizing? So standardizing means we are making the values look similar to each other. Now in the data set, in the raw data set, we can see all the values are being fluctuating. Like in a sense, fluctuating means the values are being more differentiated. As we can see here, some values are 35, 29, 0, 23, 35, and some values are in decimal over here, 28. So this makes the model confusing and hard to understand. So we are standardizing the input data. So here a standardizing means we're making the all the values look similar. Like that's the meaning of this part. Like standardizing. Got it? Now how to do the standardizing part? Now std data. So this is some random like variable which I'll be giving over here. I is equal to scalar dot transform input data reshaped. Okay, the same reshaped data I'll be giving as the input for this. Now, okay, I run this. Okay, numpy array. What happened? Input data, numpy array as numpy should be small. Okay, yeah, now this is being implemented. Now, next, what to do is print std scalar print std data. Sorry, not scalar data. Yeah, like ignore this warning. It's some basic one. Like just ignore it. And we can see the output is this is the output over here. Okay, like the standardized data is being this. Okay, like all the values they look similar, right? Instead of fluctuating values we can see all similar values. Okay, now next what we'll be doing is a prediction part. Prediction is equal to classifier dot predict 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 std data. Okay, and we're going to print the prediction. Print prediction. Now we give like condition over here. If the prediction 0, over here we are using the 0 over here because it is an array. So in an array, every variable it starts with the number 0. It doesn't start from 1, it starts from 0. Okay, so we are initializing the first element as 0. Okay, like we are like if the first element in the array is 0, then what we'll do, we'll be printing the statement that is the person is diabetic. Okay, else print the person is, sorry, if it is 0 the person is non-diabetic. It is non-diabetic, else the person is diabetic. If the value was 1 then the person is diabetic. If the value is 0 then the person is non-diabetic. Now if the value was 1 then the person is diabetic. The person is diabetic. Close this semicolon. Close. Okay, now if you print this, okay, if prediction, what happened over here, print prediction indentation error. Yeah, if I run this, name classifier is not classifier. Okay, like it is like spelling mistake over here. Classifier, the person is not, like ignore this like this warning, like ignore this. Now, as we can see, the based on this input data, the output is 0. Okay, I will just taking out this prediction over here. So not this print string data, right? Sorry, I'll be removing this to avoid the confusion. Now we can see clear 0. Now based on this input, the output is 0. 0 means what? The person is non-diabetic. Now see, as you can see here, 0 and the person is non-diabetic. So based on this, the model gave the output. Based on this input, the model gave this output. Okay. So this was the coding part for a predictive diabetic machine learning model. Okay. So this was a proper guide over here. So the link for this, like the code link, I'll be sharing in the description, and I'll be sharing even the CSV file, that is the diabetes dataset. I'll be sharing that too in the description, so that you guys can access it and start a project, right? So I hope you guys like this video and found this video interesting. So please like this video, and please share it with your friends so that even they can do the projects as well. And don't forget to subscribe our channel. The important part is don't forget to subscribe our channel before you go out. Okay, so this is all for today. Let's see you in the next video. Goodbye.